Hey everybody, it's Randy here. Welcome to another video. So today I'm going to go over the basic data types and data structures of the Unreal Engine 5, and of course this is applicable to pretty much any other version of Unreal Engine. So we're in our blueprint, and I've already created some variables just called test variable 1, 2, 3, and 4. And if you want to create another variable, you just click on this plus, and you can pop up a new variable. You can name it. And then this is the menu where you select what type of variable you want it to be. So to this first variable I created a Boolean. And a Boolean, if you don't know what that is, it is basically a 1 or a 0 in computer science, or true and false. So it's just off or on. And then you have these variables here, which are number representatives. So byte, integer, integer 64, float. Those are number representatives. And then you have name, string, and text. Those are all like actual alphanumeric characters. And really, the main difference between name, string, and text is strings. Like if you're going to manipulate the characters a lot, you're going to want to use string. There's a lot of built-in functions to manipulate them, reverse them around, do whatever you want with them. Where name is actually case sensitive, or it's case insensitive, meaning you can put in capitals or whatever you want. It's always going to be the same. And text is typically used for anything you're going to put on screen and show to the user themselves. We also have vectors, rotators, transforms, structures, interfaces, other object types, and enums. Today, though, we're just going to go over some of the basics, and we're also going to go over some actual data structures themselves. So we just have a singular data object, and we have something called arrays, sets, and maps. So let's go into the infamous 3D Paint. All right, so we have bytes, we have int 64, and float. So what's the difference between all these? So these can be positive or negative values, but they can only be integers, meaning no decimals. So integer only. And I know my handwriting is awesome. Where these can be decimals. But the biggest difference then between these three is the amount of storage they take up on your computer. So byte is equivalent to 1 byte. So if you don't know what that exactly is, numbers are represented in computers in binary form, which is just a 0 or 1, kind of like Boolean. And so a whole byte is 8 bits. And a bit is a singular digit, and it can be 1 or 0. So 8 of them, 8 bits, is 1 byte. And so whatever number you have in here can be represented by a singular byte at maximum. And it can be positive or negative. So if you have a number that exceeds beyond the storage, you have to store it in an integer. And if it goes beyond that storage, you have to store it in 64. But it can also represent negative values, like I said. But how they're actually stored is, so this is like a 1. If you like want to convert stuff, you can see this as a 2, a 4, an 8, a 16, a 32, and so on. And so what this means is, like, let's say we have 4 bits. And so you're doubling every time. So this would be equivalent to the number 2. And if you set this one to 1 as well, then you would add both of these columns together. So it'd be 0, 2, 4, 0, 6, and so on and so on. However, though, when you get into negative numbers, this final bit is just a flag for the negative number itself. So if I wanted a negative 1, it's kind of weird. Set this flag. So we have that flag 1, and we're going to set all of these, besides the last one, off. And that is equal to negative 1. But what's going on here exactly? So when this flag is put on, it means this entire thing is now negative, and it's equivalent to the maximum negative number. So we have 1, 2, 4, 8, 16, 32, 64, 128. So now this is equal to negative 128. So if you set all these to 0 right here, this whole thing, negative 128, and so in order to get anything less than that, you have to start turning on the other flags. So we turn on this, and that is 64. So now we get negative 64. You turn on that one, negative 32. You turn on, 1, 2, 4, 8. You turn on that one, you get 16. Then you get 8, and then 4, and 2, and then now you're to negative 1. So you've turned them all on and gotten to negative 1. And so the integer is greater than a byte. I think it's 2 bytes, but I'm not actually 100% confident on that one in Unreal Engine. And then int64 is 64 bits. So that's going to be 4 byte, or that's going to be 8 bytes actually. 8 by 8, 64, yeah. So integer is 8 bytes, meaning it can be a huge number. And the actual massive number it can be is the lowest number it can be is a negative 2 to the 63rd power to positive 2 to the 63rd minus 1. That is the maximum number it can possibly be. Okay, so like I said, so that's the maximum value for the N64 value. And that is millions. That's more than millions. That's huge. If you need that number, I'd be surprised. Like I said before, float, all that is just any decimal value. So, moving on. So we kind of talked about already how the difference between the strings, names, and text, but now we're actually going to go over the actual data structures themselves. So you have like a singular object, like a float, a byte, an int, a string, a boolean, but then you can store them further in arrays. We have sets, and we have maps, all right? So arrays can hold a bunch of values of any type. So you could hold a bunch of integers, booleans, structures, objects, whatever you want to do. In our example, we are just going to hold some numbers. So 0, 1, 2, and 5. All right. And so what you could do with this array is you can remove values from it in any position. You can insert values in. You can change them around. You can do all that you want to them. And then with sets, what you do is the only difference is sets cannot have duplicates. So no duplicates. All right. So if we had this same set, what, I have 5? Okay. So we have this same set, and I tried to add in the number 2, it just wouldn't do anything because it goes through, it checks, okay, there's the number 2 already, I'm not adding it in because it already exists. But when it comes to objects, however, though, if it's the exact same object with the exact same values, it's not going to add it in. So that's really the main difference. They're really useful. If you don't want duplicates, use a set. If you want arrays, use an array. And typically 2 sets are actually better storage-wise, and they're more efficient usually. That's not always the case, so it kind of depends on what you're doing. But then we have maps. So maps are kind of special, and they're really useful. So you have something called keys. You have something called values. So think of this as like a dictionary. And in a couple languages, they're actually called dictionaries. And so you look up a word, being the key, and you get a value for it. So let's say we have the key of bird, dog, cat. And these are just strings, okay? And so these are the keys in the map, and they're all equivalent. They all point to a value. So let's say that we have the value of 5, 8, and 9. And here's the thing, too, with maps. The keys can pretty much be anything that's not a Boolean. because Boolean can only be 1 and 0, and there can't be duplicates. There cannot be any duplicate keys. So we can't have the dog key and a dog key. If you try to put in another key and value and you tell it to be dog, it'll just overwrite this old one. So if you have keys, they're going to point to, let's say this just points here, points here. So if I call this map, and a lot of times in codes like map.get or something like that, whatever it may be, and we tell it cat, it's going to give back to me 9. And there's also a lot of functions too where you can call on the map object you've created and it'll give you all the keys back, and it could possibly give you all the values back just in like a new array or a set or something. Now with the values though, there could be multiple duplicates. Values can't see each other, but the keys can. So you cannot have duplicate keys. And so that's really like a lot of the main data structures that you're going to be using. Now there are more you can use in Unreal Engine, just not in the actual blueprints, besides if you want to create a new object or a structure or an enum. And so let's go into the actual Unreal Engine itself and kind of put some more context to stuff. So remember before how I said booleans can't be anything but an array? Well, as you see here, they've implemented that to show you that as well. You can't turn this into a set or a map. So it can't be a set because then there'll only be 2 values, true or false. Not possible. So we're going to turn this into an integer. And so we have an array. Let's make an array. And what you can see here is we have array elements. They're typically called elements. And so we can add a bunch of elements. These are their indexes, and we can make them whatever value we want. And there can be duplicates. And so we can take this. Is that the one? Oh no, I changed this one. I did this one, yeah. My bad. So we can call this one. So this is what the array object looks like in blueprints. And what we can do is call it. You'll go to utilities, go to array, and here's all the functions you can call on it. So you can add an item to the array, add a unique item, append the array, which just means you're going to add something to the end. Clear removes all elements, contains. We'll search through the array for a certain thing. So let's say we can search for 5, and it'll search through the entire array for a value, and we can kind of see what it'll look like. So we can see it's coming true because it did see it. So, all right. So then there's also some more. Let's go back to utilities. There's a lot more, but you can kind of go through here and see for them a lot of them yourself. So get is getting an actual value, and the index. This is, I think this is for. So if we have a float, change variable type, I don't care. So a lot of times when you try to do contains, it'll want to get, you'll have to pass in what's called an index, which an index is the location within the array. So if you see here, index 0, we always start at 0. And so 0, 1, 2, 3, 4, 5. So if I wanted to get this value of 5, I would have to pass in this value of 3. And I could pass it to the string. And then I could play. Oh, I didn't compile it. Oh, no, I did. So you see, it's getting the number 5. So now I'll show you a set. So we have a set. So we can add a value. We can add 5. And again, this is the same thing with indexes. And I can add a 6. But watch what happens when I try to add, another 6. Try to add a 6. Duplicate elements are not allowed in set properties. So it will not let me add a duplicate. And the set has a lot of the same functionality that the array has. So if you go to the set, You can see it has a lot of the same stuff. It doesn't have everything. Array is a lot more versatile. However, sets are very useful, and you can intersect them together and combine them as well as arrays, which is a really cool feature. And then finally, we have maps. So like I said, keys and values can be pretty much anything. Besides keys cannot be booleans. So right now we've set our key, or when you go and actually go here, you can go set, go to map, you'll get a choice for a key, you get a choice for a value type. So here, we're just gonna set it to integer, like we have it, but we can set it to booleans, okay? And so if we compile it, and we go to add a new map element, we'll see this is the key value, this is the value. So we can try to add another one, but it won't let us because it's automatically going to set it to 0 on default. So we have to change this because there are no duplicate keys. But look at that, just duplicate values. You can have duplicate values. I set that to true. I can set this to 55. I can add another one. And what I can do now is I can go ahead, grab it, and I can call it. Go to utilities, go to map. You can add new values, clear, contain, find. You can grab all the keys. Remember what I said about that? You can grab all the values. You can find the length of the map, which is just the amount of indexes within it. You can check if it's empty. And so right now, we're just going to grab all the values. I don't think I can actually print this out. No, I can't. But like, let's say you want to print all these out. You could do a for each loop, which goes through the map and grabs all the values. So then we can just put that into string. We can just go ahead and compile this. There we go. And you can see it pushed out all of the values. So there's only 3, false, true, true. But you can make the map to pretty much anything you want. Besides, keys can't be booleans. Because if you try, it won't let you. See, when I do it, it turns it back into a single data value, or you can do an array. And now, like I said before, there are a lot of other things, so I'll just give you a quick explanation. Vectors, rotators, and transforms are pretty much just structure objects with numbers in them, and we'll kind of go over that in another video. But we have structures, which structures are just user-defined, and you can put in as many variables as you want into whatever they equal. And then you have interfaces as well. Again, it's a whole nother topic. But you also have these objects, which are like classes you create, and you can actually reference them and store object references in them. And so if I go here, I can actually create an array of actors, or a set of actors, or a map. And so it's pretty cool stuff. So if I wanted to do that, hold on, let's compile it. I can go in here, I can select the actor, the key I want to be the actor, and I can set it to whatever value I want. And finally, there's enums, which they're very similar to structures, except they're just pretty much just words and descriptions, or like small phrases that you can set. They're very interesting, and there's something we'll go over. But otherwise that's all I have for you today. I'll be making some more content kind of explaining some more of this stuff. And if you have any questions, please leave a comment. I'm more than happy to answer and help you out with whatever you got. All right, everybody, take care. Have a great day.